I was just about to open my book, but my computer would not cooperate. So.
Okay.
But it's okay. So graphs and like graphs of polar equations is what we're doing.
Okay.
So the first one is complete the table for the polar equation and plot the corresponding points in the equation is r equals 3 cosine 2 theta.
Okay, so they want you to make a table of this and then graph it based on that table?
Yeah, in the number over 4.
I'm sorry, what? What's the left-hand column?
Well, it's the table that I have is vertical, but the left is r and the right is theta.
Okay, so pi over 4. So what's r when theta is pi over 4? Or do they give you that already?
They don't give you.
Okay.
They don't give us any.
So let's plug it in. What's the cosine of 2 theta?
Cosine of 2 theta. If theta is pi over 4.
Huh?
So can we put that in our calculator, or?
Well, no. Multiply 2 times pi over 4, you get pi over 2. That's one you should know. I mean, you can put it in your calculator, but you should know the cosine of pi over 2. In other words,
yeah. So
you want to always be able to redraw cosine and sine curves.
Yeah.
Well, this is pi over 2 right there. So r is 0.
Okay.
What's the next one? They just want you to make up the rest of the table, or do they give you theta values?
They give us theta value.
Okay, what's the next theta value?
Pi over 2.
Okay, what is 2 pi, or what is 2 of that?
2 pi, and that, so that would be 3.
2 times pi over 2 is what?
Oh, that's just pi.
Okay.
So then it's negative 3.
Negative 1 times 3 makes it negative 3.
Yeah.
Okay, what's the next one?
3 pi over 4.
Multiply that by 2.
6 pi over 4.
Which is?
Which would be 1.5.
Well, reduce it. Reduce 6 over 4.
Oh, so it's just pi over
3 pi over 2.
Yeah, 3 pi over 2. So that would be 0.
Okay. And the last one is bound to be pi.
Yeah.
Okay, what's cosine of 2 pi?
2 pi cosine, that's 3. So
Well, start with what the cosine of 2 pi is. It's 1. And then we're multiplying it by the number 3 to get that.
Yeah.
Okay. Is that all of the table?
No, it goes on. It's 5 pi over 4, 3 pi over 2, 7 pi over 4. But I think I can do it.
Okay, now what's before we spend all that time doing that, what's the next step? Is to graph it?
No, it's just to find the corresponding point
No.
with the theta value.
With the XY values? Oh, in other words, this was the job, is to find R given those things.
Yeah.
Okay.
Yeah.
Okay, so you can figure out how to do the rest of that.
Yeah.
Okay, let's go on then.
The next one is, it's the same kind of equation, or, no wait, no, never mind, I don't need to do that. The next one is,
Now, do you have to graph? Do you have to graph that?
No, there's another
Okay.
set of problems that you have to graph.
All right.
So the next one is draw the graph of the rose curve, state the smallest theta interval that will produce a complete graph, and the equation is R equals 3 sine 30. Oh, 3 theta. Sorry.
I was going to say, that doesn't sound right. Oh, 3 theta. Okay, I get it.
Yeah, I saw the.
So they want you to graph this. So in order to graph this, how have they taught you how to graph it? They don't want you to do it on your calculator. They want you to do it manually, probably, and they want you to make a table and then graph that series of points. What?
They've been teaching us to graph it on our calculator.
Okay. You have a TI-84?
Well, 83.
Okay. Well, let's see. We want to put it in polar, right?
Yeah.
So let's see if I go down to that and go to the right, that's polar. And then we want to define y, and r equals 3 sine of theta, or rather r. Whoa. Hold on. This is weird. Oh, I know what I'm doing. I keep forgetting that with this calculator, you can't type on the thing. So what is it? R equals 3 sine of 3 theta. So 3 sine of 3 theta. There we go. All right, let's graph that and see what we are looking at. Well, let's determine our window. Theta max is 2 pi.
Yeah.
Theta min is 0, and I think going from 0 to 2 pi should graph one complete loop of the rose curve.
Yeah.
I
got the same thing when I put it in my calculator, where it doesn't really show.
Doesn't show anything at all, and your window looks like this also?
Yeah.
So the question is, what do we need to do with that window? This graph makes me think that it's not zoomed in close enough. Although, yeah. I don't know, this is a little weird that we would get this graph. Here, let's hold on a moment. Let me see what I get when I plug it into Wolfram Alpha. Okay.
I don't know what's coming up then because
Well, let's see. The y curve goes from, on mine, goes from -3 to 2, and the x goes from -2.5 to 2.5. So y, we've got the x going from -2 to 2, and we've got the y going from -4 to 4. It should show something.
yeah, even if it's like out of the window, it should show like a line coming from 0, 0.
Your calculator showed this same thing, huh?
Yeah, basically.
Huh. Well, that's weird. I'm not sure what's going on. I don't know, but that's okay. Let's look at it in Wolfram Alpha. Now the only thing, yeah, it does say theta goes from 0 to 2 pi. So you can answer the question. However, it's worth knowing how to graph these manually.
Yeah.
The reason we had the first question was because we can now go back and we can draw a theta of 45 degrees and a length of 0. There's 1 point. In other words, let's go through graphing this from what we have here. I know there are a bunch of more points, but let's not spend the time doing that. But let's make sure you know how to graph this. Surely they want you to know what this means. So the first thing I look at is theta. Okay, that's 45 degrees. It's going to go out in that direction a 0 amount, which means the point is right here. That's the first point. At pi over 2, that's a vertical line. So it's going to go, that's the angle, pi over 2, but it's going to go in a direction -3, so it's going to go all the way down to there. So there's our next point. In other words, when you get a -r, you just go in the opposite direction. You with me?
Yeah.
Okay. And then 3 pi over 4 is 135 degrees, but it's going to go 0. So it comes back there. And then at pi, which is 180 degrees, it's up 3. So, I mean, it's out 3. So that point right there is that last entry on my table. So there is the x, y coordinates for this. And if you gradually go through, this is also a rose curve, I believe. And if you gradually step through these instead of in increments of 45 degrees, I believe you get this kind of a rose curve. Something like that. Let's see, is that the sine rose curve or is that the cosine? That's the sine rose curve. The cosine differs because you know you have to, cosine rose curve, I believe, must go like this. I'm not sure. I'd have to graph it and see. But I know one of them stays on the x-axis and one of them clings to the y-axis. The sine rose curve, the 3 theta is how many petals it's going to have.
Yeah.
So that's why we got 3. And if we graphed this manually, when we got to 3 pi over 2, in other words, this point right there, that's minus 1, so that's minus 3. So that's why that point is on the curve. And in fact, let's look at this. When theta is 0, we've got the sine of 0 times 3. That point is our curve. When theta is 45 degrees, we've got 3 times that. That's 135 degrees. The sine of that is square root of 2 over 2 times 3, so we should be 3 square roots of 2 over 2. That's that point right there.
Yeah.
Okay? So let me trace the way this is going to happen. As we go, we go like this. And by the time we get back to 2 pi, theta being 2 pi, we end up right there.
Yeah.
And you could make a big table and just plot a bunch of points, figure out, step theta up by some amount, plot R, and you'll see this curve. So you can do these manually. Why we're both having trouble on this calculator, I'm not sure. But I think we can illustrate everything fine with Wolfram Alpha.
Yeah.
All right, what else do you have?
Well, the next one is the same sort of problem.
Okay.
But it's R equals 3 cosine 2 theta.
Cosine 3 theta?
2 theta.
2 theta. Okay, good. This is the one I wanted to do. Wasn't this your first problem? I think it was. The table? Yeah, R equals 3 cosine 2 theta. So let's graph this on Wolfram Alpha and see if we only get 2 petals. Ah, we got 4 petals as we go from 0 to 2 theta, or 0 to 2 pi rather. The key thing kind of to notice is where is the first point? In other words, when theta is 0, well, that's the cosine of 0 is 1. So our first point is at 3 comma 0. That's that point right there. That's where it starts from. And then as you count up from 0 to 2 pi, this thing's going to do this. It's going to go there, and then there, and then there, and like that. Ending up right back there at 2 pi.
Yeah.
Okay. Is that all they're asking you to do here is graph these?
Yeah.
Okay. And they want you to do it with your calculator, not manually?
No, yeah, with your calculator.
Yeah, because, you know, it occurred to me that if they want you to do it manually, they wouldn't have given you these large increments here. They wouldn't have counted up by pi over 4, because you don't get all these subtle points. In other words, if you count up by pi over 4, you get that point, and maybe you get that point, and then maybe you get that point, and you don't see that you really have a rose curve. But if you use a less step size, this step size is pi over 4. But obviously, we actually need another row here for 0. And when it's 0, it's 3. So the very first place it starts is right there. And like I said, it goes like this. In other words, if I used shorter angles, I would see all of these points. Whereas using these table values, it shows our next point as being there, and then it shows our next point as being down here, and you miss all the curvature.
Yeah.
So I don't particularly like the way they did this. They should have used at least pi over 8 as a step size, and then you would see these points that are not on the x and y axis. And you do realize that polar coordinates can be graphed on the same xy plane as xy.
Yeah.
Okay. All right. What else? What next?
Well, the next one is it's r equals 2 plus 3 cosine theta.
Sorry, r equals what?
2 plus 3 cosine theta. And for this, identify the points for 0, where 0 to 2 pi are maximum values, or identify the maximum values between 0 and 2 pi.
Okay, let's first of all graph this on Wolfram Alpha. 2 plus 3 cosine theta, is that right?
Yeah.
Okay, this is called a cardioid. And if we try to figure out where this cardioid starts from, we start with 0. Well, cosine of 0 is 1 times 3 is 3, add 2, there's our starting point right there. Okay, and that is an R of 5. And there is no way you're going to get an R greater than 5. Why? Because the maximum value that cosine of theta can have is 1. There's no way that cosine of theta can ever be more than 1. So when I make theta 0 so that the cosine of 0 is 1, I'm getting a maximum R. Right there. It's 5. Now, when I get to this point, I don't know what R is, but I'll bet it's not 5. No, because cosine of theta is never going to be 1 again, except at 0, and then again when it comes back around and comes up to 2 pi. So that's its maximum value at theta equals 0, and then again at 2 pi.
Okay.
But you can figure it out trigonometrically by making sure you understand the range on both sine and cosine. Neither sine nor cosine can ever be greater than 1, or less than minus 1. That's not to say that 3 cosine theta can't be greater than 1. It is. It's 3. but this part of it can never be greater than 1.
Yeah.
Should we try this on this calculator and see if it matters?
I can really quick.
Well, let me try it on mine too. Maybe I can figure out. So all I got to do is add a 2 to the front of this thing. Insert. Two plus. There we go. Only this was 2 plus 3 cosine of theta. Boy, I'm not even close here. I thought it was 3 cosine of theta. Well, I would say it's a problem with my virtual calculator. It may just not like polar coordinates. But the fact that yours is doing it also is strange, because I've done polar coordinates on these calculators before and they've always worked. And we're going from 0 to 2 pi in steps that are quite small.
Maybe
Go ahead.
if your calculator's in degree mode, it doesn't work.
Ah, it was in degree mode. Let's put it in radian mode.
Yeah, because I just
That's the key.
did it in.
That's the key. You're right. There it is. There's our cardioid. Wow. Pretty crappy looking cardioid, but I mean compared to that, huh?
Well, if your
My
Windows,
X needs to go to further. In fact, if I just make this X go to like 4, I'll bet that solves the problem. Not quite. Oh, we need to go to 5. What am I thinking? Yeah, we need to go to at least 5. That's where that maximum was. So X,
yeah.
let's make it go to 6, and then we'll see the cardioid. There we go.
And then if you do zoom square, then it'll be more of a circle.
Square or box?
Square.
Huh. Good to know. Oh, I see, because that makes the x-axis and the y-axis the same increments. Whereas when I messed with the x-axis, I only changed it. I didn't change the y. Okay. So that's the secret, is to make sure you're in radian mode. Okay. Well, that's good to know. I learn something new every day.
Cool.
All right. So we got the maximum on this. What else do we have here?
The next one is 3 cosine 3 theta.
R equals what?
3 cosine 3 theta.
So that's a rose curve that should have how many petals? 6? Three. How come the cosine 2 theta had 4 petals? And yet, I thought that whatever this number was is how many petals the rose was supposed to have. Yet when we did cosine of 2 theta, we got 4 petals. Let me just change this real quick and make sure that that's correct. So that's a little puzzling to me. There it is, 4 petals, cosine of 2.
Yeah.
Okay. Whoops. Oh boy, what did I do here? And we need to know the maximum on this one?
Yeah, it's the same thing.
And it's 3 cosine of 3 theta, right?
Yeah.
Well, what's the maximum value that the cosine of 3 theta can have? Before I graph.
3.
No? Remember, the maximum value that cosine of any angle can have is 1. So the maximum value of this is 1 times 3 is 3. So 3 is going to be the maximum value of R.
I thought I said 3.
Well, you did, but not to the question I asked. Just misunderstanding. I said, what's the maximum value of cosine of 3 theta? And the answer to that is 1.
Yeah.
The fact that it's multiplied by 3 means that it's 3. So that's just miscommunication on our part. I apologize. So yeah, 3. And in fact, were you supposed to graph these also?
Yeah, that's what it says.
Okay. Notice that the one thing about the rose curves from cosine is the first curve, or the first petal, is always on the x-axis. That's because the very first point is right there. When theta is 0, r is 3. Now, what's the question say? What are all of the points where maximums occur?
Yeah.
Okay.
Well, no, it's just where is the maximum R value?
Okay.
R value.
The maximum R value is going to be 3. The question is, it looks like it occurs at a theta of 0, and it also looks like it probably occurs at a theta of, what would that have to be? Let's see, if we have a theta of 3 pi, no, let's see, let's think for a moment. Where is that equal to 0 or 2 pi? Well, clearly 3 theta equals 0 when theta equals 0, but it also equals 0 when theta equals 2 pi over 3. In other words, when theta equals 2 pi over 3, then 3 theta equals 2 pi, and the cosine of 2 pi is also 1. So on our graph, this angle right there is 2 pi over 3.
Yeah.
And
well, the way I
R
did,
is 3 right there.
So the way that I did that was divide 2 pi by 3. Because like,
right.
Because then they're all going to be equally far apart.
Right. And then there's clearly one other point right there. And what is that going to be? That has to be a theta of 4 pi over 3. Making 3 theta 4 pi, making cosine of 4 pi 1. So those are the 3 places where R reaches a maximum.
Yeah.
And R is 3 at all 3 of those angles. And in fact, on one of your previous questions, this one, actually this one, there's only one spot where you have a maximum, the cardioid. And that's when theta is equal to 0 or 2 pi.
Yeah.
But there's no point in here where cosine of theta is going to be 1. the only places cosine of theta is 1 is at 0 or 2 pi. So since there's no coefficient in front of that, you don't have multiple maximums.
Yeah.
But with rose curves you do. In other words, every part of the rose has that same maximum. Every petal, on both the sine and the cosine. Okay, you got another one?
Well, the next one that you have to do is analyze the graph of the polar curve. So when it says analyze the graph, what does that mean?
Well, give me the curve first. Or is it giving you the graph?
It doesn't give me the graph, but it's a pretty basic. It's just r equals 3.
R equals 3. Okay, well, that's good.
That's just it.
That means that regardless of what theta is, r is 3. Well, what is that? That is a circle of radius 3. In other words, when theta is 0, r is 3. When theta is 45 degrees, r is 3. When theta is 90 degrees, r is 3. And it just is a circle.
Yeah.
And therein lies the value of polar coordinates. Notice the xy coordinates for this equation. X squared plus y squared equals 9. Which is easier to work with? R equals 3 is much simpler. And there's a lot of curves that are much easier to work with polar coordinates than they are xy coordinates. And also the other thing is that when you work with xy coordinates, you can only work with functions. Well, you can work with relations, but you have to worry about whether something is a function or not. When you work with polar coordinates, there's no consideration for functions. It's not a factor, and that makes it more robust and dynamic also.
Yeah.
All right, what's another one?
R equals 2 sine 3 theta.
What kind of curve is that?
That's going to be a rose curve.
Okay. It's going to have 3 petals. And the first petal is not going to be on the x-axis. In other words, the first petal, the first point is right there. And now as theta counts up, when theta gets to pi over 3, then the sine of 3 theta is equal to 1 and r is equal to 2. So at pi over 3, that's like 60 degrees. We would have that point right there, where r would be 2. The distance from the origin to that point is 2. Okay. And I believe sine rose curves end up looking like this, do they not? Yeah. Pretty sure that's the way it looks. Well, I don't have the y-axis in the right place there.
Yeah.
Where this is minus 2 right there. In other words, when I let theta equal 3 pi over 2, then I'm taking the sine of 9 pi over 2, which is the same as the sine of this must not be minus 3 pi over 2 here. Oh, yes it is. Excuse me. Okay. The sine of 9 pi over 2 is 1. It's the same as the sine of pi over 2. So how do we end up down here at minus 2? Is this the right curve? Let me graph it here. 2 sine of 3 theta. So this point right there doesn't come at 3 pi over 2. It must come at, in other words, the sine is equal to minus 1 at 3 pi over 2.
Yeah.
But the sine of 3 theta would be the sine of 9 pi over 2. In other words, if I let theta equal 3 pi over 2, then the sine of 3 theta is 9 pi over 2, and that's 1. Times 2 would be a positive 2. I'm doing something wrong here. I can't figure out what it is. The sine of 9 pi over 2, if I take away 4 pi from that, I'm left with pi over 2. So that should be a positive 1 at 3 pi over 2. Well, I don't get it. I'd like to see it traced out, because it must be, let's see, it starts from 0, goes to 90 degrees. 90 degrees is where you get that there. In other words, at pi over 2, we have the sine of 3 pi over 2 being minus 1. So this point that I'm graphing right here comes at pi over 2. In other words, let's be clear on that, because it's a little confusing. I was confused, but now I'm not. So if I'm tracing this thing out, I'm starting at 0. I haven't gotten to pi over 2 yet. I don't get to pi over 2 until right there. In other words, here, I'm only at 45 degrees. I get back to the 0 point at pi over 3. In other words, when theta equals pi over 3, 3 theta equals pi, and the sine of pi is 0. So tracing out one of these petals happens when you go from theta going from 0 to pi over 3. By the time I get to pi over 2, theta equaling pi over 2, I'm here. And now if I keep going, I get to there, and eventually by the time I get back to 2 pi, I'm back to there. So it's a little confusing, because it looks like on the polar curve that point comes when theta is 3 pi over 2, but it doesn't. It comes when that is 3 pi over 2.
Yeah.
3 theta is 3 pi over 2 is where that point comes. When you graph it on your calculator, does it trace it for you slowly, or does it just show up automatically?
It traces it.
Okay, so you can see how it's doing. It's too bad it doesn't have like theta counting off from 0 to 2 pi as it traces it. And then you would see that you get back to this point by the time you just get to 60 degrees. By the time you get to 90 degrees, you're down here. All right. What else you got?
Well, the next one is
How about
find the length
what is
of
this?
that'll be just
It's a straight line
oh yeah.
with angle theta. In other words, it's saying that at that angle, did I state that right? Is it r equals theta? No, it's theta equals, this is what I meant to say. Theta equals, in this case, pi over 4. And that would result in this graph of a straight line. The only thing that matters is the angle. It's pi over 4. It doesn't change. And r can be anything along here since we haven't specified it. If we're saying, okay, cool. Do you have any other ones you need to identify?
Yeah, the next one is find the length of each petal of the polar curve in the equation is r equals 2 plus 4 sine theta. Sine 2 theta.
Find the length of each petal. Now this is not a rose curve. I believe this is a cardioid. We do the 2 plus 4 sine of 2 theta. 2 plus...
Well, when I put it into my calculator, it came up as like a rose curve, but the petals in the second and fourth quadrant are a lot smaller than the first and
Okay.
third.
I see. Yes. Interesting. I haven't seen one of these before. And the question is the lengths of the petals. And by that they mean the distance from there to there, the distance from there to there, and the distance from there to there. So first of all, we have to figure out where does this point come. Well, that's clearly a maximum for this function. So what is theta right here where my cursor is?
Pi over 4.
Yeah, because then 2 theta would be pi over 2, and that's where the maximum comes from. And what is that maximum right there? What is r equal to right there?
Let's see. So
always remember the maximum value that sine of any angle can have is 1.
okay, so it's not, it's less than 1.
So r is 2 plus 4 times 1. So 6. So r is 6 right there at pi over 4. Okay?
Yeah.
Now, what is that point?
That's just, wouldn't it be, 6 pi? No.
Hold on a moment. Yeah, just a second. Let's see. Well, first of all, these little loops are going to come when this thing is minus 1. Right? When the sine of 2 theta is minus 1, then r is going to be minus 2. And even though these look like plus r's, remember that r of minus 2 merely means it goes in the other direction. So this can clearly be an r of minus 2, and since the smallest that the sine of 2 theta can be is minus 1, and where does that occur?
That occurs in the second.
Normally it occurs at 3 pi over 2, but in this case that means it's going to occur at Why can't I do the math in my head here? So we want 2 theta to equal 3 pi over 2. So theta must equal 3 pi over 4. So this part of the curve right there is theta of 3 pi over 4. And it's down there in the 4th quadrant because r is equal to minus 2 there.
Yeah.
Okay. And then it keeps looping, and it gets down to here, which is clearly the same distance from the origin as this point was. So r must be either, r's got to be 6 there.
Yeah.
So 2 theta has to equal pi over 2 or 5 pi over 2. And if it's equal to 5 pi over 2, then theta would be 5 pi over 4. So theta right there is 5 pi over 4. And sine of 2 theta would equal plus 1. And so we would have a length of 6 in this direction. In other words, 5 pi over 4 goes this way here. And we're going to have a positive 6, and so we end up with that point right there.
Yeah.
We keep tracing, and we come up to that angle, where r again is going to be equal to minus 2. And do you need that angle, or do you just need the magnitudes of these things?
Just magnitude.
Okay. So that's 6. That's 6. That's minus 2, and that's minus 2. No, hold on. No, I screwed up here. When theta is 0, r is 2. So this curve starts right there. Then it starts counting, and it gets to here. In other words, there's going to be that looks like 2 units, but it's got to be minus 2 units. Yeah. In other words, there are going to be places where this thing is r is 2. There's 1. There's 1. There's probably 1, even though that looks like minus 2. That could be an angle going in this direction and then minus 2 back. All right. Do we have this answered or not?
Yeah.
Okay. I guess the only question, that's clearly plus 6, and that's clearly plus 6, mainly because we cannot get a minus 6. There's no way to get minus 6 of r, and yet that clearly is plus 6. And that's the same distance, so that has to be a plus 6.
Yeah.
Now, as far as these r's, that could easily be plus 2. That could easily be plus 2. But it also could be minus 2. And we'd have to go through the tracement to figure out whether we're looking at a minus 2 r there. In other words, when sine of 2 theta is minus 1, r is going to be minus 2. And that could be a minus 2 or a plus 2, depending on what theta is, and so could that. But since they said maximums, I guess I would go with we could figure it out real quick here, but we're actually out of time. And I have another appointment that I'm going to have to call and tell them they need to do it online. Because it is snowing like a mother out here.
Yeah.
All right, Luke.
I don't know how hard it is. It's snowing here. My windows are blocked.
Yeah. All right.
My brother
I didn't want to go out anyway. So I will talk to you next Wednesday, Lucas.
Okay.
Bye-bye.